kind of your problem. All right. Go ahead.
You distribute the 4.
Distribute. What about this one?
Distribute the negative.
Yeah, make sure you put it on both of them. Okay, now?
Combine that change. Add the 1 to the 19. Divide the negative.
Anything else?
Flip the side.
Oh, yeah.
That's definitely what I said.
Because we divided by a negative, we have to flip the inequality, and for the graph, which we are graphing these. So if negative 10 is in the middle, it'd be negative 11, negative 10, negative 9. Open or close circle, going to the left. All numbers less than negative 10. Couldn't put Humpty together again. Radioactive egg. Okay, 35. All right, on 34, do you guys remember what the TP symbol means? And. So the final, these are the ones, these are the harder ones, where you have to simplify the final answer to get what they combine to be. 35 is an or, though. It's kind of the opposite of and in a way, not really, but means something else. We'll say that. But you just solve them separately. If you get that part right, I'll give you all but half credit. So these are worth like 2 each. Okay, so there's nothing tricksy about this first part. The last part that's the tricky part. This was the hard lesson we did this chapter. Lots of fractions on this page, by the way. So don't freak out. Unless you get a whole number, I guess. Okay. So you guys remember this? When I go to graph, well, okay. I guess I'll just put -1, 0, 1. So where's -1/4 at? Over here. When I go to figure out what this is going to look like, I'm going to put the lines way above the graph. X is greater than or equal to -1/4 should look like that. My final answer I'm going to put on the graph. X is less than 1/3. It's 1/3 of the way to 1. So it's right there, and it's going less than this direction. Okay. If this had been an and statement, what would we have used?
They both touch.
It's where they're both at. Where are they both at? Here to here. That's where they're both at. That would be and, because it's got to be this and that. So it's only this and that from here to here. Is this point included in 1/3? In both of them? No. So it'd still be an open circle. This point is included in both of them, so it'd still be close. That's not the answer, though. I'm just saying that to help you with 34. This is an or statement. So what do we use if it's an or statement?
With everything.
Everything. It could be this or that. It doesn't have to be both. It could be either. So what's covered by either this one or that one? Everything.
All real numbers.
So the final answer is all real numbers, and the graph is solid line going both ways. So these are like the two answers, final answers. All right, it's floating away. 37. Okay, absolute values. So these were 34 and 35 were like the two hard kinds. Absolute value, this medium. Yesterday we did absolute value equals. You guys remember that? Have we set that up yesterday? With the absolute value equals. Okay. Absolute value, let's say 3x minus 1 equals 7. How did we set this up yesterday?
Negative 7 equals.
3x minus 1 equals 7, or 3x. Remember doing these yesterday?
Oh, yeah.
And when, or Tuesday maybe? Okay, that was yesterday. Now, what if I change it to like a greater than?
Would be negative 7 less,
Okay.
or is the other thing?
It's kind of the same. It's greater than or equals 7, or less than or equal to negative 7. Okay, but what if it's a less than or equal to?
Negative 7. No.
This is the one where it's between. What's it going to be between? 7 and negative 7. So in that, yep. So that one was like one solid line instead of two separate things. Yeah. Okay.
Is that if it's less than, that's less than, right?
Yeah, this is for less than. I don't know. For me, it kind of helps to think of it. If it's less than 7, it's like contained by 7, so it's like contained by negative.
Yeah, okay.
That's. But I was trying to tell you guys need to think of a trick for yourself, though. Whatever works. Okay, this is a less than, by the way. But what do we do first on these absolute value problems? Yeah, minus 19. We want to get the absolute value by itself over here first before we try to set it up. So we got a less than situation.
So negative 2.
So it's this guy. Okay? Now, if you forget and you like set it up like this, it's still almost right. So I'll give you like partial credit, but it's better. I mean, let's just get full credit. I mean, so it's negative 2. Yeah, it's between 2 and negative 2. I think the problem is a lot of people are directionally challenged and they can't read this from this. I guess my best advice is less than looks kind of like an L. Okay? Less than kind of looks like an L. And greater than is a backwards L, so not an L. Directionally challenged. That can be a new, oh, then you want to get x by itself in the middle. So add 6 to all sides, and then 5 by 5. We got lots of fractions on this page. Did you guys finish page 51 yet?
Yeah.
Yeah, some of you. Yeah, we gotta graph these. Okay, 4/5 is a little bit less than 1, right? So I'll just do like 0, 1, 2. So 4/5 is right about there, most of the way to 1. 8/5, if you divide it, is like 1 3/5 or 1.6, if you use your calculator. So that would be a little bit past 1.5. And then x is between these two, so that means it's between those two. Alright, that was, what was that? 39, got one more? Is this, no, that was 37, this is 39. Okay, it's a greater than that, which is good, because we need to do one of those. X plus 3, oh, this is a weird one. You guys remember the weird one? Probably not.
Have a negative.
It's got an X outside the absolute value.
That's weird.
I think we did this on the equals, but we didn't do it on the greater than, but
Here,
it's similar. Alright, you guys want to guess what we're going to do first? Not really anything different.
Add 9.
Add the 9 and
Subtract.
2x. So I'll just go ahead and put minus 2x on the same line. There we go.
Then subtract 9.
Nope. Okay,
Don't subtract.
we're ready to set it up now. How do we set up the greater than? Was it the in between or the or?
Or.
The or. So this one is x plus 3 is greater than, so, or x plus 3 what? Less than.
6 plus 2.
Yeah, the opposite of the right side. So we switch the inequality and the negative stuff. Positive, negative. When it has x's outside of the absolute value, you kind of have to check your answer and make sure it actually works. Yeah, one of these doesn't actually work. Okay, anyways, what do we do when we have x's on both sides?
Get 1 on the side.
Yeah, let's add 2x on this one. It's an ugly greater than. No, I'm about to do this one. I'll subtract 2x on this one. And then what do I do at that point?
Split it.
It's basically -1 right there, so I'm going to divide by -1. So x is greater than 9. Okay, when you have x's, we did a couple of these, we didn't do a lot of them. When you have x's on the absolute value, outside the absolute value, like this problem, sometimes your answers don't work, so we kind of need to plug it in and see if it actually works. You can just kind of treat it like an equation though. If I plug in 1 up here, 1 plus 3 is 4, absolute value of 4 is 4. If I plug in 1 here, 6 minus 2 times 1 is 4. So
It's not working.
it does work. You treat it kind of like an equation. Because it's not actually, equal to 1, the answer is not actually 1, it's actually, you can plug it, we should have just plugged in 2, I guess. But yeah, it's gonna work. Anyway, I'll plug in 2. Do you guys know why I'm plugging in 2?
If you plug in anything, it should be the same, right?
It's gotta be greater than 1.
Oh.
So if I put in 2, let's see if that actually works. 2 plus 3 is 5. Is that greater than 6 minus 2 times 2? 6 minus 4 is 2. Is 5 greater than 2? Yes. Anyway, this one seems to work. What should I try and plug in for this?
8 smaller than that?
No, x is greater than 9.
Oh, 10.
So, okay, let's see if 10 works. 10 plus 3, 6 minus 2 times 10. It's like 6 minus 20.
Negative, so it's true, right, which is correct.
Yeah. Okay, actually they both work. I thought one of them wanted to go. The reason, yeah, they both worked. But when we combine them, x is greater than 1. I'll just put 1 and 9 in there. X is greater than 1. Okay, if it's an or, what are we going to use? Where they both are, or everything? Everything. So really the answer is just this one.
That's the bad thing.
Yep. Greater than 1. Yes, 41, or 44, 45, 44, I guess. I'll help you set them up and you guys will solve them. Or maybe you help me set them up, let's put it that way. 3 numbers whose, oh shoot, this is trickier than I thought. No, we're still doing it. Find 3 numbers whose sum is 54. So how would I write that? 3 numbers whose sum is 54. What does sum mean? Add. So how can I represent the 3 numbers? 3 different variables.
A, B,
They're not.
C.
They're not consecutive numbers, so I can't use like n plus 1, n plus 2. They're just 3 random numbers whose sum is 54. The largest number is twice the smallest. Okay, well, do I know which of these is the largest? No. It doesn't matter. So I'm just going to say, let's say A is the largest and C is the smallest. Like big, small, medium, small. So the largest number is, what do I put for is? Twice the smallest. Twice. How do you do twice your age?
Times 2.
Times 2. Twice the smallest. What did I say the smallest was going to be? C. Okay, and then it says, and the other number, so what must I mean by the other number? It says the largest number is twice the smallest, and the other number is, what did they mean by the other number? The largest number is twice the smallest, and the other number, what's the other number?
B.
B. It's the one we already used, the one they didn't talk about. The other number, B, is,
6 less than the largest.
what's 6 less than mean? Minus 6. Is 6 less than the largest? What was the largest?
A.
Okay, so basically we're going to use substitution here. We're going to have to double substitute. So I'm going to replace, in this original equation, I'm going to replace A with 2C. And B I'll put in a minus 6. You guys remember substitution, right? We did a little bit, but it's mostly from way in the past. So I'm replacing A with 2C because A equals 2C. I'm replacing B with a minus 6. Okay. Is this solvable?
Yeah, a little bit.
Yes.
No, because we still have 2 different variables. So how do I fix it? I'm going to replace this A with 2C again, another 2C. Now we got all C's. So we have 2C plus 2C. It's a little bit harder than the other ones. So, how many C's do we have? 2 plus 2 plus 1. Add the like terms. Okay, once you guys figure out C, how do you find the other 2 numbers?
Algebra.
Once you figure out C, how do you find the other 2 numbers?
Oh, you plug
Plug
it in.
it in. So, if I put C right there, this will give me A. If I put A right there, A minus 6, that'll give me B. So once you figure out C, plug it back in to get all 3 numbers. Alright, that was harder than I thought it was going to be. 45. A train. So, come back to that one. You guys finish that later. A train heads south out of Bloomington 1 hour after. So how did we start these kinds? Train heads south and later something's going north or whatever. We started with arrow diagrams. So draw arrows. So try and figure out what the arrows should look like for 45. A train heads south out of Bloomington 1 hour. Don't worry about the numbers right now. 1 hour after a northbound train leaves Bloomington. Okay, that's enough for the arrows. A train heads south out of Bloomington, and that happens an hour later after a train heads north out of Bloomington. You guys get it? Girls are not paying attention.
I haven't seen.
Really? You have an arrow diagram?
No.
No, because you're not paying attention. Okay, I'll say it one more time. This is the 3rd time, by the way. A train heads north out of Bloomington an hour after, no, south. South out of Bloomington an hour after a northbound train left Bloomington.
I don't know the diagram. Up and down?
Train heads south out of Bloomington, so this will be like Bloomington.
Okay.
An hour later after a northbound train left Bloomington. So I used up and down because usually we think of north and south as up and down. But it's 2 arrows going away from Bloomington in opposite directions. Okay, what did I usually put on those arrows? What did we put on those arrows right here?
R equals.
R and a T.
R, right.
Remember, distance equals rate times time. We don't know what the northbound or southbound train's distance is, but they are telling us a rate and a time. So we're going to plug that information in. It says the first thing they told us was the southbound train left an hour after the northbound train. So if this guy left an hour later, would his time be shorter or longer than this guy? Shorter. If you left later, then you've been traveling for less time, right? So his time we're going to call T minus 1. And this guy's time is just going to stay T. Okay, let's keep reading. The northbound train is going 63 miles an hour, and the southbound is 57. Where do those numbers go?
On the rate.
The rates. So the northbound was going faster, 63, and the southbound was going 57. Are these 2 distances equal or not? Are these going to have to be equal?
No.
No. There's no reason to believe they're equal right now unless they tell us it is. But what it does tell us is the last fact I haven't read. How long will each train have traveled? So how much time will each train have traveled when the trains are 243 miles apart? So where do I put 243?
Over the whole thing.
Yeah, let me move Bloomington out of the way here. That means from here to here is 243 miles. So what's the relationship between distance, distance, distance?
63, 50, equal.
Okay, the train distance plus train distance equals total distance. I think I might have put one of these on the test. I can't remember. But there might be one of these on the test, but I'll go over like the day before, like a
Plus
similar,
243 equals, right?
whoops. I'll go over the day before what, I think similar example to what's on the test, but it'll be something in this neighborhood. All right, what should we, so now we just have algebra left. What's distribute?
Combine the terms.
57t. Notice I put a tail on my t so it doesn't look like a plus. You could use a capital T.
Combine the terms.
T plus t. It still looks kind of confusing even with that. That come out as 300 exactly.
Yeah.
300 divided by 120. I believe it's 2.5.
Yeah.
What does that mean in, well, t equals 2.5, what does that tell us?
You plug it in. So you can get
That tells us t is what we use to describe the northbound train's time. So that's like one of our answers. North train, 2.5 hours.
How'd you get hours?
We're talking about miles per hour, so the time would be in hours. If we were measuring like they were traveling 30 feet per second or whatever, that
Wouldn't you
then the answer would be in seconds.
multiply 63 times 2.5 though?
63 times. If you want to, that would tell you 63 times time would tell you the distance of the northbound train. They said how long are they traveling, which means how much time are they traveling. Okay, so that's the northbound train. How do I find the southbound train's time?
You do 2.5 minus
Yeah,
1.
t minus 1 is what we use for the southbound train. Brianna, have you seen these problems before? We did a couple of them like earlier, but we did a number of them back in Algebra 1. Yeah, t minus 1 is the southbound train, so you do 2.5 minus 1 is 1.5. We haven't done a ton of them. We spent like a day or two on them. Way back when. They're difficult, I know, I get it. Okay, 46. Don't forget to go back and do 44. 46. Dave has $3,000 more in money market account than he does in the savings account. So before I keep reading, that's probably, that's an equation that we could probably just go ahead and write down. How do I write 3,000 more in the money market than the savings account?
N plus 3,000 equals N.
Money market has more money, so to make them equal, there's a few ways we could write it. To make them equal, we could say it's 3,000 more than the savings, plus the savings would equal the money market account. You could also say money market minus 3,000 equals savings. Yeah. But the money market has 3,000 more than the savings, so 3,000 plus the savings equals the money market. Okay, let's keep reading. The savings account pays 0.5%. So savings account doesn't give you much money. Have you guys got a savings account?
Yep.
Do they give you like a quarter at the end of the year? Have you ever noticed?
Rack.
Yeah, like 3 cents.
I think I made 12 cents.
Good job, Caleb. But you also made 12 cents for doing nothing.
Yeah.
However, the problem is inflation's like, 6% or whatever it is now, I don't know. So you kind of lose money if it just sits still. You guys, I'm not going to teach inflation. You guys can do that when you do personal finance or something. Basically, the value of the money goes down over time and things cost more. So you kind of lose money when inflation's happening. All right, anyways. I lost my place. Okay, we're getting 0.5% from the savings account, which is less than 1%, and 2% from the money market account. How much is invested in each account? How much is invested in each account if the annual interest that he earns on the 2% is 180 more than 5.5%? Yeah, these are a little harder than I want them to be. Okay, so he's going to get 0.5% of his savings account. What is 0.5% as a pure decimal?
0.05.
Okay, you got to move the decimal back twice. So 0.5% is the same thing as 0.005. And that's what he's getting out of savings. That much out of savings. That much interest. On the, what was the other? Money market, you got 2%. What is 2% as a decimal? 0.02. So he's getting 2% on the money market account. Then it says, he's getting 180 more. Let me write this a little bit neater. This account is making $180 more than this account. So how do I write an equation? Do I add 180 to this side to make them equal, or 180 to this side to make them equal?
To the left.
Right. This guy's making more, so to make them equal, probably shouldn't use an S if you can help it, because look right there, it's confusing. To make them equal, we need to give this guy the help. Okay, how can I solve? It's a trick we used on 44. What can I do with this? M equals this. So what do I do with this?
Plug it in for now.
Put it in for M down there, substitution. Then I'm going to just have one variable equation, because this will turn into an S thing, and I can solve it. Okay, it's 0.02 times n, so we need to do 0.02 times all of that, s plus 3,000. I probably should have called the savings account A or something. I'll turn the A there. This will be my savings account. That looks a little less confusing. You don't have to, but... Okay, I'm going to let you guys finish that. Once you get A, is that the answer? Well, that's one of the answers, but they probably want both, so how do I find the M?
Plug in A for.
Right, plug in your S or A, whatever letter you use, plus 3,000, that will give you the money market account. Toughies, those are toughies, huh? So you got last one, Chlorine bleach typically, this one looks small. Chlorine bleach typically contains 5% chlorine, and Samuel needs 3 liters of a 2% chlorine solution. How much water? Aaron. Okay. So, typically contains 5% chlorine. How much water and how much 5% bleach should he mix to get 3 liters? Yeah. You know what? Yeah, let's stop there. That's fine.
Yes.
These were a little bit harder than the word problems we did
Stop at 46.
earlier. Yeah, 46 is fine. Just a little bit too much. A little bit.